Welcome, everyone, to the Operations and Maintenance for Controlled Environment Cannabis Cultivation webinar. So glad you're here. Honored to have you join us. Wherever you are on your journey in the cannabis industry, we are glad you're here. And we're going to teach you a lot today and have a great lineup for you. My name is Rob Eddy. I'm the Resource Efficiency Horticulturalist for RII, Resource Innovation Institute. My title is a goofy title. What it really means is I'm a horticulturist, greenhouse nerd, plant growing nerd, but I'm really want to teach you how to reduce energy, reduce water, reduce emissions. So, and as they say, the best preachers are the ones that have a dark, sinful past. Here I am. So I've wasted a lot of energy. I've wasted a lot of water, and I put a lot of nitrates down the drain, and I've sprayed tens of thousands of gallons of pesticide. So you're going to help redeem me. Now that you're all rolling in, we'll get started. We want to thank NYSERDA and the Offices of Cannabis Business Management for hosting this webinar. They are great partners. You are so lucky to be in New York and have these organizations working for you. And we find them very delightful to work from our angle. And all this brings together these education principles that we are going to teach you today. Next slide, please. So our agenda is that we're going to have introduction and context, and also joining me today from RAI is Carmen Azzaretti and Bryce Carlton. They're the wizards behind the curtain that are going to manage this webinar, and all the technical aspects are also going to jump in and help me where we need. So I just want to get those introductions. Then we're going to have some technical discussions by our expert panel, see the HVAC equipment, understanding, selection, and maintenance, then climate control optimization and equipment tracking, and grower perspective. Then we're going to have 20 minutes for question and answer, and then we'll have a sign off at 3 o'clock Eastern time. Feel free to ask questions in the chat. The panel and I will try to get to as many of them as we can, either by writing the response or during the question and answer period. A lot of you will probably want to know this. A recording of today's presentation will be available after the webinar. It'll be emailed to you. Okay, so you're in. If you need to walk away, if you need to leave early, don't worry. You'll have access to this whole thing. Also want to let you know we'll be conducting polls and knowledge checks throughout the webinar, and that helps us know who you are and what you're doing, what your interests are, and we can tailor our responses to that. Next slide, please. All right, introduction. First of all, here's one of those polls. We're going to leave the poll up on the screen, and you can answer at any time during the next section. Shouldn't take you very long, but we're not going to wait for everyone to answer. What kind of facility are you cultivating in or plan to cultivate in? If you can answer that, that would be wonderful. That'll help us tailor our answers to your questions. Let me close it out on my screen. Okay, who is RII? First of all, we are non-profit. We are not selling anything to you today. We are here to bring you objective information, right? And that's what you really need in the cannabis industry. The cannabis industry sometimes reminds me of the cryptocurrency industry, or now it's artificial intelligence, where everyone wants a piece of it. There's all this information going around, and a lot of it isn't useful. We're here to help you sort through that. We have network in the science community and the industry, and we're here to bring you facts, okay? We are formed in 2016 in Portland, Oregon. Since 2020, we've had USDA funding, and we are now a partner with the U.S. Department of Energy for further funding, so we have that kind of governmental support. We spent the first 3 years, so you want to know this because you want to know if we're cannabis experts. We spent the first 3 full years of our existence helping the cannabis industry, because they needed this information the most, because there wasn't anyone out there providing unbiased information like universities normally do, because the universities weren't allowed to talk about cannabis. And we help crop producers like you through education, training, policy, and benchmarking. I'll explain that in a little bit of detail, but not too much. We'll get to the fun stuff soon. Next slide. Here's our network. So we've been doing this for a long time, and we have a vast network. So we bring all these folks together and help us to get things done. So the utilities, the governments, the efficiency programs that have incentives that'll help you pay for some of your capital expenses if it brings down the energy use. You're the producers, of course, the crop producers, the supply chain, the vendors. We have a lot of members to RAI who are the vendors, and the standards community. You figure out what it is that, how we should all be talking and measuring things. Next slide. So we bring folks together in industry working groups, and this is the fun part, and this is what I manage, that we bring folks from all those different diamonds you saw on the last slide, and we have a topic that we want to cover, like HVAC, or maybe it's lighting, or maybe it's water, and we focus on that, and we develop best practices. We publish these best practices guides, and they're free, and we give them out to anybody who wants them. We also develop climate smart methodology, right? Okay, and here are those best practices guides. These are free. These, you can go get these right now. In fact, just do it. We'll put a link to this page where all these are in the chat. And this is, again, that non-biased information about all these specific topics related to cannabis or CEA. CEA is controlled environment agriculture, which means greenhouses or indoor farms, right? So if you hear that term, that's what we're talking about. All right, next slide, please. We also do benchmarking. What that means is measuring. And you can share with us information from your facility. We'll sit down and show you how to do this. We'll do it with you. We have a Power Score. It's called Power Score platform. And we can look at your energy consumption, your water consumption, and your productivity, and we can show you what your KPIs are, your key performance indicators, and to show you how efficient are you. And this will be really helpful, because a lot of times people in this industry talk about how they want to be good for the climate, but they don't have any metrics, and we can provide you those metrics, and you can compare yourself to other folks. You can use it for your marketing, or maybe you use it for your board meeting to show everyone that you really are putting your money where your mouth is. All right. Benchmarking is free to growers. All right. So you can learn more at the Power Score web link you see at the bottom of this page, and we'll put that in the chat as well. All right. Next slide, please. The learning doesn't stop after today. You can look at you can access the virtual classroom, which has the recordings of live workshops we've already done. We've already done 2 for New York. This is the 3rd of a 4 workshop series. There's other downloadable resources, tips and tools, and those best practices guides that we discussed. All right, next slide, please. I'm very excited today. This is going to be a great webinar, so I'm fired up. The purpose is to help New York cannabis growers improve energy and water efficiency, no matter what kind of facility they have. We're going to convey scientific insights and industry expertise. All right. So we are very committed to providing you this unbiased, accurate information, and to provide it in a way that gives you context to your location, whether you're a small grower or a large grower, sophisticated, simple, whatever it is. Okay. Assist cannabis producers and their design and construction partners with what they need to know to stay competitive and comply with the regulations. So we'll talk a little bit about that as well. All right. Next slide. So we're going to do our introductions now. Again, I'm Rob Eddy. I'm the resource efficiency horticulturist. My background is in greenhouse and growth room management. So I was at Purdue University for 20 years, managing their research horticulture greenhouses and growth rooms. Prior to that, I worked at a big corporation at their global headquarters with their greenhouses. And I've also done horticulture therapy. So I've got kind of a broad spectrum of greenhouse skills. And that's why I love being here today. I'm going to have the panelists introduce themselves now. We'll start with Chip. Chip, you want to jump in and introduce yourself in Desert Air?
Sure. Hello, everyone. My name is Chip Seidel. First of all, would just really like to thank the Resource Innovation Institute. Rob and the group there have been tremendous. These webinars provide a really wonderful opportunity for interaction between manufacturers, cultivators, engineering groups, and helps to really pull everything together. So I'm the resident dehumidification and HVAC nerd. I've spent the majority of my career in that space, working for several different large manufacturers. I started my career out in the disaster restoration space, so trying to dry things as quickly as possible, and have spent the last roughly decade in the indoor cultivation space. So working for groups that are designing the most efficient and effective ways to control that environment. And I'll be talking about some of that here today.
Great. Thank you, Chip. Robert, can you introduce yourself and series to the audience?
Certainly. It's glad to be here as well. My name is Robert Fisher. I'm an engineering lead and technical advisor at Ceres Greenhouse Solutions. Our aim is to build the most efficient greenhouses and hybrid buildings available to people to grow, whether it be cannabis or other kind of agriculture. My background is pretty much controls nerd world. I started off as like a computer integrated manufacturing world where I worked at companies such as Train, working in laboratories that were helping to analyze the equipment and make sure it was going to pass all the new SEER ratings. From there, I went to Intertech Testing Laboratories, where I did the same thing, but for everybody's company, for all of the industrial products out there, the performance testing and safety testing. And then at that point in time, I kind of transitioned into the agricultural world, where I spent about 7 years directly integrating systems with cannabis, very large scale cannabis facilities throughout the US and abroad. And now at Ceres, we're doing this with greenhouses and at the most efficient ways to grow. And there's a lot of technology that actually gets baked into these projects. So that's what we're here to talk about, is the technology and how to use all this technology as a user once you got it.
Great. Thank you, Robert. I'm so glad to have the two of you here. I couldn't ask for a better expert panel for this particular subject. So let's dive in. So, Carmen, do you want to tell us the results of our first poll?
Yeah, it looks like we've got a lot of people doing small indoor buildings, almost 40%, and then a little bit of a scattering between warehouse, vented greenhouse, and sealed greenhouses. And then we do have a question right now that I think it would be good to just kind of broadly address of which has a lower environmental impact, a sealed greenhouse or controlled environment warehouse, and which is less energy intensive to operate. Which I think is just, it depends. There's no clear answer. And that's kind of what we're going to explore today, is all the little ways that you can make one or the other a little bit more efficient.
Excellent. Thank you. Yeah, we will definitely get deep into that topic during the next two presentations. All right, next slide, please. So before we get started with Chip's presentation on HVAC equipment, we'll do another poll. Go ahead with the next slide, please. All right, this is a knowledge check. Now, don't worry about this one. This is one I don't expect you to know, but I just want to kind of get your brain working. Compared to a field crop production in summer, a greenhouse, one, has about the same insect and disease problems, has less insect and disease problems, or has more insect and disease problems. Now, I know a lot of you haven't grown in a greenhouse before, but I just want to get you thinking about this, because here's a hint. The answer is probably not what you're thinking. All right, Chip, take away. We're going to leave this poll up. Chip, you can take away it on your presentation now.
Very good. Wonderful. Okay. Well, let's just jump right into it. So first, I just wanted to address from a high level, what you should be looking for and what you should be considering. So when you're doing any type of indoor cultivation, your HVAC system really is like, if you want to think of a car analogy, it's really sort of the drivetrain of the facility. So you've got your lighting, you've got your airflow, you've got your nutrient blend, you've got your watering, and all that stuff that you're doing, in particular with the lighting, that's getting your plants to go through their metabolic processes and mature as quickly as possible to get the characteristics that are desired. And so in order to do that, you've got to be able to remove the waste. And in that case, it's really the transpiration. Plants breathe and respire by giving off moisture. And so it's important to be able to remove that. If you're able to, we'll talk a bit today about vapor pressure deficit. And without getting overly technical, it's essentially making sure that the vapor pressure, so lower vapor pressure is indicative of drier air, higher vapor pressure is more saturated air. So you want to make sure that the air is dry enough around the plant so that it can transpire and give off its moisture efficiently. That then allows the plant to replenish that moisture by drinking up through its root system, getting its nutrients, and it's sort of turbocharging the grow process. So these systems are very expensive. So select wisely and try to view the entire cost. So think about how much it's going to cost to operate the equipment. We look at energy consumption between your lighting and your HVAC. Those are the two main energy drivers for indoor cultivation. And they match up pretty well. I think with LED systems, you can use a little less energy on your lights than on your HVAC, but they're pretty close. And we'll talk about it today, but there are some pretty wide differences in the efficiency of these HVAC systems that are available. And I've certainly seen utility bills that are really high. And if you're able to save $1 million or $2 million a year on your utilities by being more efficient, that certainly hits your bottom line. We talked about the tighter control of VPD. The tighter you're able to control that, the higher your yields will be. So that's really the revenue side. And then what's looping all this together is no matter how good your system is, if you're not keeping up on the preventative maintenance, it's going to take more energy to run the system. It'll be harder on the system, and it won't last as long. So that's really sort of to kind of kick us off here. I'm ready for the next slide. So just to put this, into perspective, and we'll talk about cannabis. This is a 5,000 square foot canopy example. So, in this situation, this is based off of, we had a customer that was coming to us looking to improve their operational efficiency and improve their bottom line. We were able to get them a better HVAC system that increased their yields by 10%. And you can see that drives an additional $450,000 in revenue for them. So really did a lot to help their profitability standpoint. And in addition, we were able to help save them 25% on energy. And that turned into $100,000. So again, think about the size of your facility. These are the type of numbers that we're playing with. So it certainly is important to invest in the right equipment that's needed to be able to get you to where you want to be so that you can get those yields and keep those costs in control. Next slide. Okay, so what should you be considering when you're looking when you're evaluating HVAC equipment for the indoor grow space? So really, first and foremost, look to partner. There's a lot of good manufacturers out there. Look to partner with the manufacturer that's in the space, that has really deep application knowledge, been in lots of facilities, done this for a while, attends trade shows, participates in industry events. Look for equipment that's purpose-built for this application. And I can say, as indoor cultivation has really taken off, in the beginning, folks were trying to do the best they could with equipment that was really designed for other applications, whether it was just large commercial buildings, you have other dehumidifiers repurposed from other applications. And while that stuff was the best that was available at the time, the indoor cultivation environment is very, very long run times, really high loads. And if the equipment is not designed for that, you're going to see shorter life, more problems, and it's better to get out in front of that with some purpose-built equipment. Next is consider the total installed cost. So a lot of times, especially with HVAC equipment, there's ducting considerations, there are sensor considerations, there's commissioning. Do you want to be responsible for getting all this stuff set up and running by yourself, or do you want to have a group that commissioning is sort of included? And for those that don't know, by commissioning, I mean the startup of equipment to make sure that everything's working in unison and your environment is perfect. And we'll talk a little bit more about that. And then lastly, and I think really important, is energy efficiency. There's all sorts of rebates available. I think if you're building out a new facility, I'd be getting with your lighting and your HVAC partners to see if there are rebates available in your region. I actually think RII is going to be doing a piece on this as well coming up. So that's something to stay tuned for. There's a lot of really good rebates out there, all based on efficiency. Next slide. Okay, so kind of going back to the original poll question, the size of your facility, there are different ways to approach your HVAC for your indoor cultivation spaces. And essentially, there are three main categories. So I'll just sort of go through those here. The first is most typically used in smaller setups, but that is standard air conditioning, so comfort cooling, to address the heat load that you have from all the lights. And then you're going to also need independent dehumidification. A lot of times you'll see these units hung from the ceiling inside the grow space to provide that extra horsepower for dehumidification. Next up, integrated, the next option is the integrated direct expansion HVAC systems, HVACD systems. So we'll talk a little bit more in detail about these, but this is essentially one system that handles your dehumidification, your heating, and your cooling all together, all integrated, taking advantage of the efficiencies that are available. Those are typically found in small to medium size and large facilities. They scale really well. And then the last system is similar, but that is an integrated chilled water HVAC system. These are typically found in the largest facilities out there. They're more expensive to set up, but you get some pretty good efficiency gains with them. And there are some other advantages from a maintenance standpoint that we'll talk about later. So those are the three main categories that make up the systems in indoor grow. Next slide. Okay, so I just want to quickly go through these. So AC plus dehumidification, you've got two systems. One is going to be putting out cool air that is going to have some dehumidification, but really the design there is to cool the air. And then you have another system that's going to be taking the moist air and just removing the moisture. So for each pint of moisture or pound of moisture that's removed, you're going to be adding 1,060 BTUs to the air. So you're just converting moisture to heat. So those are the two systems. Obviously, as you're converting that moisture to heat, if you end up with too much heat, then your air conditioning has to kick back on. So you've got two systems working to try and control. You get a low upfront cost with these systems. They're readily available. Again, it's sort of standard equipment, not necessarily designed for the grow space. A little bit less energy efficient. There's going to be more maintenance. You're not going to have the remote tuning and diagnostics, and they're going to be a little bit more difficult to achieve that really smooth control because you've got the two different inputs coming in. Next slide. The next system is the integrated integrated direct expansion HVACD system. D stands for dehumidification. I'm going to give you a little bit of a higher upfront cost, a lot more energy efficient, significantly less maintenance, really good controllability, again, because you've got that variable sensible heat ratio. You're able to throttle on and throttle off dehumidification, cooling, heating to get you right where you need to be. And then these systems, they're not all created equally, but they are available with remote diagnostic and tuning abilities, especially the purpose-built systems for indoor agriculture. And we'll talk about the importance of that, but essentially you're able to view all aspects of the system remotely, and the factory can as well. So if there's any issues, they can kind of zoom in there and take a look and make adjustments and provide some support. Next question, or next slide. Okay, and the last is the integrated chilled water HVACD system. So these are going to have the highest upfront cost, but they're going to be the most energy efficient. They're going to have the least amount of maintenance. You're going to still have to maintain your chiller, and that has a lot of the standard refrigeration components. We'll talk about that a little bit later. But the internal system, the air handlers, are just going to be dealing with that low pressure water being piped through and extracting the energy that's needed to provide the control. Okay. Next slide. All right. So we've heard about these different systems. There are generalities between them, but when you're looking to set up your facility, you want to think about your geographic location. just noticing this slide, I don't think it pulled through some of the lettering on the map, but essentially you can tell by the different colors. These are different climatic regions, and the shading corresponds to the number of hours below a certain temperature, and that corresponds into efficiency. So when you're looking at a chilled water system, if there's more time where it's below a certain temperature, I think here we use 35 degrees, then you're not going to need to run compressors to do the chilling of the water. You're going to be able to utilize that outdoor energy, and you get some significant benefits from an efficiency standpoint. There are other considerations, for geographic. A lot of this equipment will be outside, so you get your remote condensers, your cooling towers for your chiller system. You're going to want to think about what are the airborne particles that are in your region. If you've got a lot of milkweed, or if you've got a lot of stuff that's in the air at certain times of year, maybe your coils are going to need to be cleaned more frequently. It's as simple as well as if it is a very harsh climate, maybe you're not going to want to locate your equipment on the roof. Maybe it'd be better to have it in an equipment closet or in a mezzanine because of ease of service and some of those considerations. And then lastly, taking your equipment locations and figuring out, all right, for this region, given my equipment, what is the best proactive or preventative maintenance plan for me, and working with your manufacturer to establish that. Okay. All right. So importance of maintenance. So really what it comes down to, when you maintain your system, you're going to get increased energy efficiency. You're going to get an increased stability of control. These systems are designed to deliver very tight control, but they assume that they're being maintained. So if you're low on refrigerant, or if you're having an airflow issue, they're going to struggle. If your filter is clogged and the fans are having to work harder to try and come through to make up that pressure gap, the more you maintain your equipment, the less equipment issues you're going to have. If you invest in the right equipment and you have some of that remote diagnostics, you can a lot of times tell that an issue is coming. Say you've got a compressor that's doing something kind of funky, or you're noticing that your system pressures are a little off, maybe it needs a little more refrigerant. You're going to be able to stay on top of that. And then lastly, the contamination control. You want to try to keep as much of these HVAC systems out of the actual grow room as possible. Because when you do have to service something and it's in the grow room, you've got all the flour there, you're up on ladders and you're trying to work on equipment. It's very easy to have some contamination problems there. So it's certainly preferable, if possible, to get that equipment out of the space. That way it can be worked on without folks needing to gound up and risking, bringing in some contamination. Next slide. Okay, so critical maintenance points. So we've got the refrigeration system, we've got coil cleaning, we've got filter replacement, we've got sensor calibration, and fan maintenance. So I want to sort of run through each of these. Some are a lot shorter than others, but these are the big bullets that we need to be taking care of if we want to ensure optimal results. So next slide. All right, so before we dive into each of the individual systems we have to maintain, I want to talk a little bit more about the benefits of the remote system interface. So it's a little difficult to see here, but if you look at the graph there, these are just a few of the points that could be monitored. But the more sophisticated purpose-built systems, almost everything about the system can be monitored. So you can see your suction line pressures, you can see your superheat, you can see your discharge pressures, you can see all your zones. We can even see some of the valve positioning for reheat and whatnot. So you want to try to invest in a system that has some of this remote ability. It'll save you in the long run. You're able to get alarms sent via email or text to the right service personnel. You're able to make tweaks on the fly to bring rooms tight, into a tighter level of control. Maybe a cultivator is targeting a different cultivar than they've done in the past, and there's some adjustments that can be made to help them achieve their results. That's really important. And then lastly, it represents a large labor savings because you're able to do a lot of diagnostics up front. And then when you do need to engage a service contractor, you know what you need, you know the parts you need, and you know how to do it. Okay, next slide. All right, so refrigeration system vitals. So this may look complicated, but if you just kind of bear with it, you'll look through. This is a schematic of a refrigeration system from an integrated system. So you'll see you've got your evaporator coil, you've got your reheat coil, and then you've got your outside condenser. So these systems can operate either in full dehumidification mode or full cooling mode, or whatever is needed in the middle to sort of match your climactic goals. So because they're very precise, we need the pressures and the superheat and subcooling of that refrigeration system to be on point if you want the highest level of efficiency and the most dialed in control. Good news is that's really easy to do when you've got remote monitoring. If you didn't, then that would be a much more tricky thing to do. Would involve kind of on feet on the ground. And I think that would be very difficult. So these same types of refrigeration checks need to be done on all refrigeration systems. So again, if you've gone the route of air conditioners and independent dehumidifiers, you may have 4 of those in each of your rooms, 4 dehumidifiers. Each of them are going to need to be checked. So it starts to become a more onerous task when you go that route. These should be checked quarterly, ideally, and that's the best way to move forward. Next slide. Fan maintenance. So it's very important to make sure your airflow is on point. So you want to be able to check your airflow, check those belts that are in the fans, make sure they have the appropriate tension, checking bearings, lubricating bearings. Really, when you've got your equipment during that commissioning phase, that's best to be able to develop these lists, work with the manufacturer to make sure that the equipment is being serviced properly. All of these are important to be able to get the ideal results. Next slide. Coil cleaning. So this really, the outdoor coils are of the largest concern. So your condenser coils, these are going to be outside. These are going to be helping to shed unwanted energy in the form of heat. So just like your home system, if they're all caked up with debris, you're not able to get that efficient heat energy transfer, and system's not going to operate as well. Your evaporator coils, these are going to be the moisture removal coils. In this application, frankly, there's so much moisture removal being done. There's almost a constant flow of water over these coils. It's very abnormal for them to have any debris on them, but it still makes sense to give an inspection. And then what goes along with that is the drain pan. It is important to make sure you clean those out periodically and keep that microbial growth down. So that's a lot of folks will clean their coils either quarterly or every other grow cycle, something along those lines. Okay. Filter replacement. So this is a really big issue. Most folks do not change their filters as frequently as they should, and it actually can have a very large impact. When your filters get clogged up, it messes with the static pressure within the units. The units are drawing additional amps to try and push air through the dirty filter, and you're not getting optimal results. So cheap insurance policy, change those filters, keep them clean, and it's going to be doing wonders for your facility. What you will also see, the point where all HVAC systems will struggle when you're getting towards the end of that flower cycle and you want to really bring out the colors and drop the temperatures and the RHs down to sort of trick the plant into feeling as though fall is coming and release everything. Though that's really where the rubber meets the road. And if you're going to have problems with units freezing up or whatnot, it's going to happen there. So really important to keep those filters as clean as possible, and great additional insurance for you. Next slide. Sensor calibration. So this is kind of a tricky one. The deal with sensors are the accuracy, what goes into the accuracy of a sensor, and the more expensive sensor systems are able to read more quickly. But all sensors will eventually come out of true. So it is important to develop a routine. I know, Vasella is a manufacturer of high-end sensors. They make a nice handheld sensor. Get yourself a good handheld sensor that you're happy with, and set up a routine of going around and calibrating your sensors. If you're off by a few degrees or a few RH points, it makes a big difference. So try to invest in good sensors. Make sure your sensors are not, don't have, like, for instance, a light shining directly on them, or they're not right in the supply of the HVAC system. Make sure that they're at canopy height. Work with your manufacturers. And again, during the commissioning process, that's a really great time to get free advice on where to put sensors and how to make sure you're doing all the right things there. Okay, next slide. Maintenance labor. So we talked about this a little bit, but really when you're trying to go through your PM process, think about on the front end when you're purchasing equipment, what is that going to do for me down the road as far as maintenance? Is this equipment that I'm getting a great screaming deal on? Am I going to be able to, how many pieces of this equipment am I going to need? How many service points am I going to have? Do I have to hang it in the room, or can it be ducted in? Are there remote diagnostics? Is the equipment purpose designed for indoor agriculture? Am I going to have warranty issues or anything like that? So just an important thing to consider. It does become an arduous task, especially if you've got multiple pieces of equipment in multiple flower rooms. It can be a big expense. Next slide. Okay, so who's going to service the equipment? This is a topic of importance, and it really depends, I think, partially on the size of your operation. But you need somebody with commercial HVAC experience. So, residential stuff can look a little bit similar. A lot of the principles are the same, but they really are different beasts when it comes to being able to troubleshoot and diagnose and perform diagnoses on these. A lot of facilities that are above a certain size, I think, benefit from getting some in-house help here. So hiring somebody with this type of experience. A lot of the manufacturers in this space, I know Desert Air does, will offer training classes that are free, where folks can come, learn about the indoor grow application, learn about how to maintain that equipment, and develop relationships with the internal service folks that we've got. And that's something that depending on, no matter whose equipment you buy, you should be looking to take advantage of those opportunities. And then the last thing is that the service personnel, so whether it's your internal guy or gal, or if you find a contractor that you're going to work with, make sure they're there for commissioning, so that they're able to understand how everything works, and can be part of that process moving forward. And then NATE, I throw them out there. I'm not trying to give a plug there, but that is a group that does certification for HVAC contractors and refrigeration contractors. So if you're looking for credentials, that would be a place to look for. I think it's also smart to leverage your manufacturers. If you've bought equipment from a manufacturer, ask them, who's a good service contractor in this area. The manufacturers know. We know who's good. We know who's not good. We know who to stay away from. And all the incentives are aligned to get you the right service contractor. That way your equipment is performing optimally. Okay. Okay, so the importance of commissioning, we've been a little bit talking about this the whole time, but the high quality dedicated manufacturers in the indoor agriculture space, they all offer commissioning. So, that should be a red flag if your equipment provider is not willing to be there on site with you when startup occurs. A lot of the manufacturers will also offer, even weekly meetings. I'm frequently, especially for our larger customers, personally on those calls once a week, once every other week during the beginning of their harvests, or at the beginning of their process, to make sure everything's dialed in. And then I've got access to all of our engineering resources as well. So make sure you take advantage of that. You want, before you're off to the races by yourself, you want that factory confirmation. Yes, everything is working. all the backnet connections, all the controls are working and talking with each other, and you're good to go. So I think that that's an important thing. And then ongoing, as we mentioned earlier, if you are going to be doing something slightly different, maybe you've got a new lead cultivator coming in, maybe you're going to be trying to go to multi-tier, or you're going to be doing a different cultivar, changing your media, all that stuff, reach back out to your manufacturer. We can do some tuning and testing, and we'll be able to let you know what's possible, what's not. Certainly had that conversation with folks where, hey, they want to go to a 2-tiered system, and there's things that we can do, but at the end of the day, if you've got double the square foot of canopy, I mean, you're going to need damn near double the HVAC. So that's kind of the way that works. But at any rate, take advantage of the free advice, take advantage of that wisdom. Everybody, I think, in this space is hoping to help their customers succeed. So please take advantage of that. Next slide. All right, so just to kind of wrap things up, tips for minimizing your downtime. Downtime is really scary in this space. It's if you lose control, there's a lot of value that's at stake. So be diligent on your preventative maintenance. Work with equipment where you have remote diagnostics and alarms in place. That way, the right people can be notified immediately if something starts to go wrong. Work with your manufacturer to get a suggested spare parts kit together. It's always frustrating, when somebody's got a really sophisticated and expensive dialed-in HVAC system, and there's a capacitor or a valve or a pump or something that goes wrong. That's a small dollar part, but it keeps them sidelined until we're able to scramble to get something together. So again, work with your manufacturer. They'll make sure you've got what you need. And you're ready in case of any issue that comes up. Identify a strong service partner. Again, working with manufacturer to figure out who do you recommend. Talk in the industry, and don't be afraid to hire someone. Ideally they've got the right experience, but if they don't, tough cookies. We can train them. So don't be afraid to invest in the right team to make sure you've got the results that you need. I always say farmers are some of the smartest people that I know, and it's largely because they've got all these systems in place that they're trying to manage. It takes an incredible amount of intellectual horsepower. So try to make your life easy and select partners that are pulling the same way with you. And then lastly, take advantage of the trainings that manufacturers offer. And that can be for cultivators, that can be for folks that are working on equipment. But the premier manufacturers in this space are always looking for opportunities to interact, coach, teach, and share the wisdom that we've accumulated. And I think that's it for my section. Hopefully I didn't bore anybody too badly.
You did great, Chip. Thank you so much. And I really appreciate how you boiled down some complex topics into an introductory lecture for the people who need to hear it at that level. So great job. I'm not going to slow us down by asking you a lot of questions. I do want to just make a couple of comments. I love that you're pointing out the maintenance for the drain pans and the coils, and reminding people about that. And it sprung to mind that I need to remind folks, if you're interested in reusing that condensate, because it's almost pure, you do need to treat it, but it's like a free, almost pure water source. Keep in mind, you'll need to talk to your HVAC producer and tell them that, because that might change the kind of, or the coating on the coils and the drain pan, and it certainly will affect the SOPs that they'll maintenance SOPs, because those coatings would help keep any metals or detergents and things like that from getting into that water source that you might want to reuse for irrigation. And then I just got to say, I'd love the dial-in access for HVAC that you talked about, Chip. I mean, that wasn't something that could happen 10 years ago. And the fact that you could have the company dial in and look and make sure everything is operating, just to have that peace of mind, is awesome.
Really, yeah, really makes a difference. I saw some of the questions and comments, and some of them are larger, but the one that I did want to address is somebody mentioned, an economizer. there is no reason why outdoor air couldn't be used from an equipment standpoint. However, it introduces the issue of bringing in outside contaminants, bugs, pollens, and you lose the CO2 that you're supplementing with. So just to be honest, I haven't seen it done very often, but I just wanted to kind of address that from a high level. And please feel free to reach out to me via email offline to discuss anything else. So
Great, thank you, Chip. You'll have access to their emails. We've got it on the last slide of the presentation. And Chip and Robert can also type it into the chat so you can get a hold of them after the program. And hopefully Chip will be able to answer some of your questions in the Q&A that certainly I don't have the expertise to do on HVAC, but that was a great presentation. We're going to jump into the knowledge check. Most of you answered this right. Good job. A greenhouse has more insect and disease problems than a field grown crop. And it's because it's like the perfect environment for plants. So it's also the perfect environment for insects and disease. And there's fewer beneficial insects to attack those pest insects. And the air tends to be more stagnant. So that also leads to disease. So good job answering that one. We're going to move on to our next technical discussion, which will be climate control optimization. Before I let Robert dig into that, we'll do our next poll question. If you could bring that up for me. What is your focus for the upcoming year within cultivation practices? So if you could answer this while Robert's talking, that would be great. Robert, I'm going to turn it over to you.
Thanks, Rob. Thanks, Chip. So today we're going to cruise through quite a few different topics, so bear with me. But the first thing I want to discuss is kind of understanding the type of system you have and what it can and can't do when it comes to controlling your environment. It doesn't matter whether it's a small operation with a mini split using large, or you have a large chilled water system, geothermal. They all have their own set of controls, and these controls vary as much as the systems themselves. However, it's not just about operating the systems and turning it on and off. It's really like we're talking about. It's managing the systems to meet specific humidity and temperature set points in order to have a healthy cannabis growth while saving energy, improving your operations performance. There's a lot we're doing besides just turning on equipment. When you buy equipment, there's a lot you want to look at as you're making those selections. And then keep in mind that not all control systems are equal, because you're managing something complex like a chiller loop or a geothermal system. The requirements of control is a little bit easier than thermostats and mini splits and things of that nature. So just something to keep in mind, that the equipment you're getting or using at the beginning, it's actually your strategic edge in the industry. So if you can, spend accordingly and take care of it, as we were talking about, because this stuff's expensive, and you don't take care of it, it kind of ruins it. If we go to the next slide, we can discuss kind of like in a cultivations facility, you have a lot of zoning and segmentations that are required in order to maintain your efficient and productive cycles here. During each stage of the growth process, the plant requires unique control needs. This necessitates the creation of different climate zones within that facility, allowing for precise environmental control based on specific requirements of the plant's stage of growth. On top of that, you're going to have post-growth process areas such as trimming, kitchen work, possibly some extraction according to how big the facility is. They all have their own climate and their own particular issues for control. And then also keep in mind the facility is not just for plants, it's also for humans. You're going to have areas like break rooms and bathrooms and storage and places that need climate control for those zones as well. So the zoning strategy contributes to the overall control strategy of a cannabis facility. And we try to ensure each zone is receiving the appropriate climate and control so you can have a successful operation. If we go to the next slide, we talked about this a little bit already, but each geographical region has its own climate conditions, which is going to impact your HVAC and your control strategy at the facility. Regions with hot, humid climates are going to probably require more cooling and dehumidification systems. Same thing in greenhouses, because we actually do cooled greenhouses as well, sealed, to maintain, to be as optimal as possible, to effectively remove and control the humidity and prevent growth. I mean, there's just, every region's different. Some areas that are cold, you may have to actually add other things to the system. If the plants are getting cold, we do a lot of humidification in cold areas. We also do fogging in a lot of arid areas. So you can do fogging in arid areas. So there's just a big mix of equipment, as Chip was kind of pointing out. And we're not always telling you this is the exact piece of equipment you must have because we're selling it. It's more like this is the piece of equipment you need to be successful in your local area there. You also want to follow all regulations for your local areas when it comes to safety controls. You're going to have compliance issues to keep up with, and in addition to climatic considerations. So there's a lot going on, and you just want to kind of select that carefully as you're going through the locale there of what you're picking. Evaporative cooling doesn't work where it's really humid out that well for greenhouses, and people will sell them to you. So just be careful on that. If we go to the next slide, we can kind of talk a little bit about when it comes to choosing a system, you kind of balance your need between functionality and the essentials complexity of it. The two types of systems you might consider is direct expansion, which I know Chip had talked about briefly there, as well as a hydronic system, such as your chiller. Each one of these is a little different. The DX is, circulating the actual refrigerant through the air handler there. And then the chiller is using refrigerant to cool water and circulate itself. Both work well for certain operations in certain places. They all have their place, but you need to decide if you're going to use variable or step capacity. I think we talked maybe a little bit about the variable systems. The step capacity is the one that kind of have on-off or stages, which will end up giving your grow room kind of stages of capacity. Some people don't mind because it's a lower cost. Some people with controls can kind of mitigate that if it's a full load zone. But at the end of the day, step capacity isn't always as great as variable speeds. So there's a lot of decisions you want to make there. And all those decisions kind of go back to the complexity and control of the project and the processes there. If we go to the next slide, I think we're talking about, so we don't just typically start the HVAC when we're doing these design projects. I mean, you've got HVAC, fertigation, water treatment. I know Rob just talked about capturing the water. It's kind of what we're looking at here in this project we're finishing up right now. In the basement down there, we've got an entire water treatment system. And as you can see on the left-hand side down below, it's kind of small. It shows how the water treatment system goes to a fogging as well as the fertigation areas. But what it doesn't show you is how big this equipment is. So we typically try to model this equipment into the buildings to make sure it'll fit and that the clients are actually going to get what they need. Because when you buy something from somebody and it shows up on a huge flatbed truck and you didn't really decide whether it could fit or not, that could be an issue for your facility. And you could end up adding quite a bit of renovation costs if you're not careful to re-engineer to be able to utilize that equipment in your building. If we go to the next slide, we can talk about in a cannabis cultivation facility, the required expertise encompasses both your agricultural side, your grower, as well as engineering knowledge. On one hand, we have growers that focus on the biological aspect, which is nurturing the plants and ensuring the optimal growth. And then they also do pest management. We've talked a little bit about that, strain selections, and what the actual environment they want. But on the other hand, you should have some facility engineers or access to them that tackle your operation aspects and make sure the systems and equipment function correctly and effectively. They're usually involved during the design and the layout of your facility. So hopefully you've had help there, troubleshooting the equipment failures and potentially planning for future expansions or upgrades. The role is integral to ensuring smooth workflow and maintaining conditions necessary for plant growth in your building. So if we go to the next slide, you can kind of see we've talked about a lot of things in your building and a lot's happening on there. So at this point, I'm almost with the mindset, it seems like, control systems are almost mandatory, it feels like, in a grow facility. You can get by, small facilities with a little bit of, not much, but when it comes to actually managing complex systems in a grow facility, not all control systems have the capacity to handle the level of complexity. When we compare the differences between an off-the-shelf controller or a full-fledged building automation system, kind of like you're looking at, there's a real big difference there. On the shelf is kind of designed to turn things on and off with preset features. It's less expensive, easy to install and operate. However, these systems are limited in the customization of what type of systems they can control. On the other hand, a full-fledged building automation system, which is kind of a norm anymore for a building, is fully customizable solution for complex operations. These systems offer a high level of customization that can be tailored to your needs at the grow facility, not every need of every grow facility. We manage things like environmental controls such as temperature, humidity, lighting, CO2, air circulation. Everything is being managed by controls at this point because it's a little too difficult and costly for humans to do that. And then in addition to managing controls, building automation can also offer advanced features such as real-time monitoring, data analytics, predictive maintenance, a lot of things we can bake into the control systems. And then if we go to the next slide, I know Chip talked about this a little bit, but the sensors are very important also. When you actually are spending a lot of this money on control systems in the building, accuracy is a very important aspect when it comes to this operation. Precise monitoring of the environment, like your temperature and humidity, CO2, can impact your yield. And using high quality, accurate sensors with control systems ensure this environment stays at the condition you want. And the data you collect, you can then analyze and use for valuable insights later in the future. When you select the sensors, we always like to use aspirated sensors, which have a little fan across them to pull air across the sensor, making sure it actually can see the changes occurring in the room and it's not sitting in a little hot pocket there. And then the placement of your sensors are always important. A lot of times you'll get a call that it's hot in a room or something, and there's direct sunlight or there's some kind of high intensity light shining on a sensor. Maybe there's a vent blowing on it. I mean, something that's tricking the system. So also when you're building the system and deploying it and going through your commissioning, all these little things will work themselves out once the building is starting to come alive. On the next slide, we talk a little bit about the commissioning process here. And this is an essential part of the project. It's not just the startup, because we do startup in all the systems we sell here internally at Series, but we do the startup, we'll come out and make sure it's working. But typically we always like the owner to have a third-party commissioning engineer that's been hired that will actually validate that the system's saying what we say it's doing. So when you do the commissioning, I know we've talked about like all integrated manufacturers will do the commissioning, but typically they'll come out and do startup one component. If they sold you the HVAC, they'll do that part. If they sold you the lights, they'll do that part. You really want somebody that does total integrations that kind of take the ownership of all of that. And when they come out and they start your building up, they're making sure your HVAC's working the same time your lighting, your irrigation, and all these systems are working in harmony together. So that's a very big part of the commissioning point in our world. And that's when we get heavily involved. Obviously design phase is a lot. Project managing is one thing, but commissioning is when it all comes alive. Staff training forms another crucial aspect for your operation. It's not just about familiarizing the staff about the controls, but it's also providing them with a comprehensive understanding of your system's operation as a whole. This includes the interactions between the different systems like we were just talking about, and then also encouraging proactive engagement amongst staff is key to running a business here. The staff should be encouraged and vigilant if they see something or feel something in the environment that's off, to kind of run that up whatever slide you have. You should have an SOP to take care of that, because this approach really, besides watching data points, is the other way for early detection of potential issues, and kind of getting a timely fix to something that could be a pretty big catastrophe otherwise. Once you get your building started up, we could probably go to the next slide, and then you're operating and you're actually doing great. You're going to hit a point in time where you're going to notice something starts to change, maybe if you're not keeping up with your maintenance, and your performance of your equipment will start to drop. And I know we talked about this a little bit, but there are some common issues for your equipment derating performance, such as the gradual wear and tear of it just kind of getting old on the equipment. And I know Chip talked a little bit about the continuous operation at a grow facility. The equipment should have been designed and developed to almost be running all the time. It's an industrial process here. It's not a home. And then an even more common is the accumulation of dust and debris, especially in the fans and filters, as we've talked about here. Even on the outside heat exchanging equipment, every time I've worked for a place that has chillers and or evaporative coolers, there's either 1 or 2 times a year that the trees are shedding all of their, like we got cottonwood and things like that. And all of a sudden it just gets blocked up and it stops working very well. So you want to keep a check on that. And then lastly, as your facility starts to age and new systems come out, you want to be more cognitive about what type of technology you have purchased in the past. Maybe you were kind of lean at the beginning and you're making money and you can kind of step it up now, or maybe you bought the best and at this point in time, it's not the best no more. And you can always do technology upgrades over time as your buildings are going there. And then on the next slide, we're going to kind of talk about the impact of performance derate in your facility, which obviously is increased energy consumption, which we've talked about. The degraded equipment often demands more energy to perform the same tasks, leading through higher operational costs. This is something that could be significantly impact your bottom line there without really counting on it. Reduced crop yield and quality would be occurring at the same time that you're now having to pay more money to grow your crop. So you're going to then end up with increased maintenance and repair costs, and it just kind of turns this little cycle where all you're doing is you start spending money to keep it alive versus, keeping your plants alive and making money there. If we go to the next slide, we kind of get into talking a little bit more about, maintenance. Regular maintenance and servicing keeps the equipment in top condition. It involves the cleaning, the lubricating, moving parts, or, replacing worn out components. Regular maintenance is pretty common. Performance monitoring of key equipment can help identify when it starts to become below optimal. I know Chip brought this up, and I know some of our systems have it as well, as where you actually can see the performance of the system live. So monitoring systems now is a much more easier thing than it used to be in the past. Your sensors and control systems need regular calibration to keep from drifting, which we've also discussed here a bit. And all of this, again, keep in mind, is feeding back to your control system. If your sensors are reading it's too hot or too cold, it's telling that entire system to do something that it's probably not supposed to be doing. So keeping all of this maintenance up to check is very important. And then the cultivation staff should be educated about the importance of this equipment and how to take care of it and identify the signs if it's starting to wear out. Beyond data points, again, your staff is going to be your first line work insight of what's occurring there. And if we go to the next page, we kind of talk about why do we track the equipment? It provides the insights for operational efficiencies and predictive maintenances. Operational efficiency is understanding how often or intensely that piece of equipment is actually being used. This information is ideal for seeing overused or underused equipment at facilities. And then predictive maintenance is more monitoring the usage patterns and allows facilities to shift to a predictive model versus a reactive model. So that's where most people should be trying to aim to get to. When we go to the next slide, we can discuss how do we track equipment usage. And there's two ways, really, two easy ways, I guess. The first way is automated systems. So if you have a control system, all of this can be basically baked into the control systems to count the cycles, to pick up sensor data to know what's occurring. The other way is to do manual logs, and that's a little bit more difficult to keep up with what you're doing. But in smaller facilities, if you're going out and you're changing filters and all, nothing wrong with keeping a paper trace of that. If we go to the next page, or the next slide here, I guess, the maintenance scheduling is a critical aspect as well. You've got your preventative, and then you've got your seasonal. Preventative, we just talked about that a minute ago. It's preventing the problems from occurring. Seasonal is kind of dynamic, where you want your maintenance schedules based on different variations in the usage. For instance, HVAC works a lot harder in the summertime maybe than in the wintertime on some situations, and vice versa. So just kind of tracking those different patterns, and then how your facility requires the staff on hand to handle that as it's occurring. And if we go to the next slide, we're still kind of just talking about maintenance prioritization. You've got risk-based maintenance. Maintenance prioritization is all about focusing on the efforts on the equipment that is most critical to the cultivation process. For instance, if the climate control systems that regulate your temperature and lighting go down, that's a pivotal problem for your photosynthesis. And then risk-based, it really in grows is kind of close to the same in my mind, because you're kind of finding out which equipment could cause the most trouble if it goes down, and then making sure that's maintained at all times. And then go on the next page or slide here. Equipment usage and tracking, still the same thing. Record keeping is crucial to understand who's coming out, who's fixing things, who's touching stuff last. Review these records as you're getting them to see if things are breaking down more commonly than others. And then, keeping track of it, because if you're ignoring this is happening, your plants are feeling it every day and every night. And if we go to the next slide, when it comes to managing your facility there, you can kind of integrate your activities with your daily operations. So you're not trying to do your actual maintenance while your plants are in bloom or grow there. It's important. Talk to the staff, figure out who's available when and where. Maybe there's off hours. People can come in if the building's being cleaned because you just churned a crop. It's a perfect time for maintenance. But at the end of the day, you just cannot not maintain your equipment. And then the last slide I think I have here is just one on standard operating procedures. In a grow facility, there's going to be a lot of SOPs. There's a lot of them. I grayed out a couple of them here and just put up 8 of them to begin with. But the ones that we're most worried about would be the equipment handling maintenance SOP. because this one of the ones that kind of talks about the correct usage of the equipment, how to maintain it, how to calibrate it. So that's a very important one for your technical facility staff to know. Staff training and management's nice to have around, so you know who has been trained on what. You can have huge risks if you have people touching equipment they don't know how to touch. They can get electrocuted, they can get, crushed fingertips. I mean, you've got a lot of bad things that can happen for people trying to fix or maintain equipment that have no idea what they're looking at. So make sure that your people are trained before you say, hey, just go over there and service this piece of equipment for me. Make sure they know how to do it. And then the last one is the emergency SOPs, like, hey, my power went out, the utilities are off, massive storms are coming. Make sure your staff are trained on those SOPs, because a lot of times all the other SOPs seem like they trump those. And at this point in the game, if you're trying to keep your building alive, those are some of the most important SOPs you can have. And I do believe that's my last slide there, Rob.
Wonderful. Thank you, Robert. I appreciate that. And I think the audience can see that this webinar is about sharing information. Neither you or Chip talks about your products. This is not a sales thing. This is them providing you balanced, non-biased information. I just really enjoyed it. Love the bit in the last slide about safety. We talk so little about that, and that's not the subject of today's webinar, but you're right. I've worked in greenhouses, and you can get hurt in a lot of ways. And so you need to have someone who's in charge of safety, just bottom line, who thinks about all these things and comes up with the SOPs, like you mentioned, that need to be developed and trained on. Carmen, do you mind doing the results of our poll?
Yeah, absolutely. It looks like we have just over 50% of people are just starting out, and I did let people pick multiple things, but it looks like we have a lot of interest in saving energy, humidity control, closely followed by temperature, and then light. So, a lot of people who are just starting out, we love to see it.
That's great. We do love to see that, because you're curious and you're ambitious, and that makes for good learning. Okay, we'll keep moving. Next slide, please. All right, so I'm going to jump into my grower perspective of the topics we've talked about. And this is, like I said, I've spent decades working in greenhouses, and so I kind of boots on the ground sense of some of these things that Chip and Robert have talked about, and I can tell you they are absolutely right. Everything they've discussed, and I'll give you that perspective. Greenhouses in particular, and indoor farms, are more machine than building. You really need to think about it in that way. This is a machine, and it needs to be maintained. It's always running from the first time you put a transplant into that facility. That climate control equipment is going to be running constantly, responding constantly to, in a greenhouse, a dynamic environment. But even in an indoor facility, the plants are growing, they're changing, they're transpiring more. When they flower, different things might happen. All sorts of forces within and without the building are forcing the climate controls to respond. All right. And this is the other part of it. Like in many machines, these things are not designed with ease of repair in mind. Often, not all of them, but you might discover this. And that's why I like Chip's analogy to a car and a car engine. I know nothing about mechanics, but I don't understand how a car mechanic can reach certain parts to do it. And it'd be so much easier if it was just out there by itself. But the fact you have to remove some things to get to the part that you need to fix, that's what a controlled environment facility can often be like. That's why you should visit other facilities, look at the sort of equipment that they have bought. For us at Purdue University, this is a picture of Purdue's greenhouse range that I managed. We found that buying a used one-person power lift that was motorized, that you could also drive from up in the rafters when you're inside it, that was invaluable for reaching certain things in a tall greenhouse safely. Otherwise, you're climbing around on rafters, and that is not something you want to be doing. It's just too dang dangerous. And so even with a machine like that, also this affects how you think about your equipment that's up there, because anything you do that high off the ground is going to take 3, 4, 5 times longer than if you were just standing on the ground. So you don't want to do a lot of repairs up in the ceiling of your indoor room or the rafters of your greenhouse room, because it takes so long. It's so inefficient because you're setting up ladders, or you're driving your little power lift around benches full of plants. It's really, really difficult. So spend your time and energy maintaining your equipment so you're less likely to have to get up there and repair it. Here's a great example on the right of a problem with shade curtains, that we didn't set a limit on how many times this automatic shade curtain in a greenhouse, it opens and closes by a motor, and the computer is, measuring the sunlight and closing it when the sun's at a certain level. We didn't have a limit, so it was opening and closing too much. And that did 2 things. 1, it burned out the motor prematurely. 2, it was putting a lot more stress on the fabric than needed to happen. Plus, this fabric was not installed with enough sag. The commissioning wasn't effective. And so after only a year, we saw rips like this in the shade fabric. And so, of course, huge problem, a lot of expense. We got a little bit of warranty, on it. But the point is, you could have paid me the entire cost of this shade curtain. I'd still lose money because I'm going to have to spend 35 hours on a power lift replacing that shade curtain in a greenhouse. Next slide. All right. So, and again, Robert alluded to this, and I think maybe Chip did. Sometimes, and this really happens, sometimes it's a $2 component that fails, and it ends up being a real problem. You lose part of your crop, or you affect the quality of the crop. So this happens all the time. And this is why what Robert is saying is so important. You've got to train your staff to know when something doesn't look right, it doesn't sound right, it smells wrong. Okay, you got to train them. And then the other part is, you've got to reward them when they come and tell you that they think something looks wrong. And if you're not answering a lot of false alarms, you're not doing your job. So if they're wrong, if they come to you and say, something seems weird in this sound or this smell, and it's okay, don't make fun of them. Tell them personally and meaningfully, say, that means a lot to me that you brought that to my attention, because if you'd been right this time, it could have resulted in this. So good work. And just that, looking your employee in the eye and telling them, good catch, even if it's a false alarm. Well, you really need to do that, or you will be sunk. And I could, if I wanted to, I could go through this list and tell you a lot of stories, but I'm not going to, because we don't have time. I want to get to question and answer. But the very first one, this is a great example. Sensor box aspiration fan. There's a little picture of a sensor box, that white thing hanging there. It has a little computer fan in it. That's all it is. It's just a little computer fan like you'd see in the back of an old PC that's bringing fresh air in so that the sensors are getting air from the greenhouse to measure. And the reason that's there is because that box will heat up in the sun and you'll get inaccurate readings. Well, those little fans, they fizzle out and you won't know it. Nothing will tell you that it is out. And now your greenhouse is operating off of bad temperature and humidity data. It's a stupid little $20 fan. And instead of waiting for them to fail, why not just replace them every year or every 2 years? So you're going to start thinking about that. What are these small components? Half of them on these lists, you could just replace them routinely and not wait for them to break. Okay, next slide. We want to get to our Q&A. All right,
let's start of our Q&A.
Oh, thank you. Let's start the Q&A. I will look at some of these questions that have come up. Some of these are questions that were in the registration survey that you asked, so we'll start with some of those. And I will read them, and we'll decide if Chip or Robert might be. Chip with the HVAC ones most likely, and Robert for the greenhouse. Okay, this is a greenhouse one. Robert, what are some key considerations you'd give to growers who are retrofitting an existing building or greenhouse that would be different than a new build?
Well, it's going to go by the structure itself originally, like what is the structure you've got up there? A lot of times we do glazing replacements. We offer ETFE glazing, which is a high performance glazing. So it's, to me, it's like I'd have to see what does your structure look like? What are we playing in? But some of the upgrades, we can do everything from light coming in to air moving out to fogging on the inside. Pretty much anything you want to do, there's a huge option list of things you can or cannot do based upon your budget, your location, and your true status that you're standing at, like today, like what you're actually standing in. So if there's things like that that you have concerns on, reach out. There's a lot of people like me and others out there that's what we were more than happy to do. Look at pictures with you, look at plans, and try to make a plan to make it right for you.
Oh, that's great. Thank you. You know, there's a question that I was hesitating to answer until I talked to you, Robert, and I also offline talked to Carmen about it, who's an expert on New York. And that is a greenhouse a viable option in New York for cannabis production? Now, my opinion, Robert, and I want you to chime in if you think I need to be corrected. My opinion is yes, it would be because, and I'm basing this off of historical information, because New York is full of greenhouses growing geraniums and lettuce and shrubs, and those are very slim profit margin crops, and they manage to be a viable business. Now, of course, they don't need to light that crop like you have to light cannabis, so that you do have a big expense with cannabis lighting. But I still think, given the value of cannabis, it would be a viable business option in New York. Robert, you want to comment on that? I know I'm catching you off guard.
Absolutely, and we would love to explore this. We do lighting layouts and lighting studies of how much sun is actually hitting a property, and also the position of the greenhouse. We position our greenhouses facing the south where we can capture the light. So it's according, again, what type of greenhouse you're using. We have a high performance greenhouse, so I'm speaking in one direction because I'm biased in how that would work, and I'm like, yes, absolutely, that would work.
Yeah.
But then again, like, yes, the answer is yes.
Great. Chip, here's one for you. It's one for both of you, but I want Chip to have a chance to answer this. The question is, we have a lot of growers just starting out. What would be one piece of advice or a golden rule you'd give our viewers to take home today for those just starting out?
Yeah, so I think if you're just starting out, you're in a really exciting phase, and you've got all these options that are being pushed forward towards you. What I would try to focus on is try to get an understanding of what your loads are going to be. And that can be, I mean, we talk with cultivators all the time and kind of look at their setup, look at the number of lights that they're using, look at the potential infiltration of heat into their facility, look at the type of watering they're going to be doing, the type of racking, and we can give them a pretty tight band of the loads. And then from there, you can really select any equipment that you'd like. We'd love it if you bought Desert Air, but you can look at other manufacturers as well. And I think that that's a really powerful tool to use. So I guess my recommendation would be, don't be shy, reach out to manufacturers in the space. And we do this over and over and over. And even though it seems super new to you, there have been hundreds of people like you ahead of you that have done this all over the country, and we've got a pretty good idea of what's going to work, what's not. Can give you some budgetary numbers and can help steer you in the right direction. Good news is that this industry is a very inclusive industry, and a lot of the people are very passionate. So that would be my recommendation.
Great, thank you, Chip. I'm going to go back to Robert. We've got another greenhouse question. Or actually, let me ask you that same one, Robert. Just any golden rules for the people just starting out if they're thinking about greenhouse?
Yeah, I mean, just know what your budget is before you start going anywhere. Know what you want to do. Do you even have a budget you need to do the project? A lot of people might take a couple steps down a path. I've seen it in the past in sealed buildings as well as in greenhouses. You take a few steps down a path. You thought you had the funding. You thought you knew what you're doing, and you just ended up in a big beginning of a project. You don't know how to finish it. So my suggestion is, if you're actually starting this and you're serious, make sure you understand what your budget looks like and what you want your building and or systems to be that you're spending that budget on, and then be a stickler with your dollars. I mean, the end of the day, we just went through all this COVID stuff. All the prices have been up for a very long time. I've actually seen a couple places where prices in the market are coming down. So start asking for that leeway if it's out there, because it's very, know what you're getting into. It's a lot that you're getting into. You're about to bite off a lot if you're taking on this process. So just make sure your heart's in it, because it's going to be there a while, or you're going to break it.
Great answer. Chip, back to you. There came a really specific question while you were talking, and one that I'm not qualified to answer. It was, what's the best system for an indoor 200 square foot grow? I believe they meant 200 square foot, not 2,000.
Sure. So 200 square foot is, I mean, we see people that are doing all different sizes of projects, but with a 200 square foot grow, honestly, I think you're going to be a little smaller than the groups that are looking for these integrated systems. So for a 200 square foot grow, what I would recommend is, again, reaching out and trying to figure out what those loads are, but you're probably going to be in the residential capacity zone. So finding a, if it's indoor specifically, finding a residential air conditioner, and then for the dehumidification systems, look for the highest efficiency dehumidifiers you can find. The other, thing I'd throw out there is the temperatures that you're trying to hold and the humidity levels that you're trying to hold. If you have some flexibility there, you can get away with different types of systems. So the principles are the same regardless of the grow size. 200 square feet is a little smaller than what we're used to dealing with, but I would recommend going that route.
Great, thank you, and I appreciate all the questions that are rolling in from our audience today. This is just what we thought. We thought this audience is going to be curious and they're going to ask a lot of great questions. Robert, back to you about solar panels. There's a question here that says, there were a few questions on solar integration. Can you speak on what things growers should consider when adding solar to your operation? What would change in their operation? Now, I know I've seen series greenhouses with solar on the head house parts, I believe. So I figure you might know something about this.
We entertain solar if possible, where possible. A lot of the large cannabis farms we play with want solar. So the thing is, you have the land for it. So the loads we're talking about, usually when you're doing solar, again, I'm thinking of a sealed greenhouse now. So I don't know if we're talking about an unsealed or sealed greenhouse.
Yeah.
But I'm going towards the big ones, to where you're going to need, a couple acres of land just to get those few megawatts of power. You're going to need to power your facility. So just having the space, but if you have the space, there's a lot of rebates out there and a lot of things that make absolute total sense there. And then if this was more geared towards a vented one, I'm sorry about that. But to me, it's like, have enough space for the solar panels, because usually if it's a big sealed garden or if it's a big industrial one, just a few on the top are not going to cut it. You're going to have some out there in the field.
Great, thank you.
But if you want one, we can do it for you. Come on out. I mean, that's what we love, things like that, because again, at that point, there's no electrical burn occurring in order to keep your farm going. So I love it.
Cool. Chip, we had a couple of questions in the Q&A about duct cleaning. Is that required in a cannabis operation for HVAC?
Yes. Yeah, it is. And I've seen a wide variety of practice here. But typically, if you're using a fabric duct system, which are very common, those can be laundered. And there are companies that offer that as a service. If you're using traditional hard duct, it is good to use a duct cleaning service. Typically, that's vacuum based. But it is important to remember that, unlike a residential system, these rooms are typically pretty clean. So you've got your filters, nothing's going to get into the duct that gets past the filters. So it's always good to do some inspections, but the videos that we see from residential duct cleaning businesses where they're pulling out these huge things of mothballs, and that we don't really see. And just be careful, if you spray anything in there, just make sure that it's not going to have an adverse effect on the plants. For further details on that, again, reach out to your manufacturer. But yes, the duct should be cleaned.
Great, thank you. I'm going to go back to Robert, and I might also have Carmen chime in on this question. Someone had a question about geothermal systems for a facility of 2,500 square feet. Now, the first thing I think of when I see Series greenhouses, I know how innovative they've been with geothermal techniques. So, Robert, do you mind trying to tackle that one? Geothermal systems for 2,500 square foot, let's say a greenhouse.
Yeah, I mean, it's
specify.
a doable thing. We do those. The cost is usually a little more costly to make the facility. So again, it goes back to budgetary. But yeah, we could do a greenhouse that big. I mean, it's a doable thing. We do it for two reasons. We do it, one, for according to where you're located, heat concentration, to eliminate or limit the amount of heating you have to use during wintertime. So that's kind of an interesting way that we do it, a little different than others. We concentrate the heat under. So yeah, I mean, it is doable, but it can get costly, especially scale of economy is working against you right now. So if you're talking about 2,500 square foot, it's easier if you're doing 250,000 or something really big, because the cost per square foot drops down. So keep in mind, as you're going out and you're asking for really small projects with really high tech, the ROI may not be there, but if your heart's there and you can afford it, then we can do it. So
Great. Thank you. Great.
And
Carmen, do you mind jumping in? Go ahead, please, Carmen.
Yeah, so geothermal is one of my nerd things, and New York is top of the country as far as geothermal heat pumps go. So there's direct geothermal, which is a bit more common, kind of broadly, and then there's geothermal heat pumps. So there's air source heat pumps, and these would be ground source heat pumps. So New York is by far the leader as far as residential geothermal heat pumps go. And NYSERDA is fully working. That's what part of the question, right? So NYSERDA is fully engaged with cannabis growers in New York State. Federal doesn't matter. NYSERDA is fully engaged. NYSERDA is working directly with the Office of Cannabis Management. NYSERDA funded this talk as well as the other ones that we've been having, these webinars and workshops. And they're very interested in bringing geothermal heat pumps into grow spaces. So if you're interested in that type of project, get in touch with NYSERDA. They are, helping kind of work to connect these different people. If you're looking for something that's maybe a little bit more state supported, trying something new for geothermal. But then you can also get in touch with, companies like Rob's company, and some of those who are doing more geothermal kind of greenhouse things. There's also some different things like root zone heating and heating kind of in the slab that can be a little bit more of those kind of, broader kind of, there's a lot of different choices you can do for heating. And one of the questions we had earlier was basically like, why aren't we talking too much about the heating of things? And I've had a question as I've learned more about the space, like, why aren't we talking more about heat? People are like, there's 500 different ways to heat something. It's easy. The problem is there's so much moisture in the air. What do we do with all of this water with these high transpiration crops? So that's part of why you hear a lot more about dehumidification and those types of systems than you necessarily hear about heating systems. But you're going to have to heat in New York for sure.
That's for sure. Great. Thank you, Carmen. I apologize. We can't get to all the questions today. Carmen, if you don't mind putting up our takeaways slide, and we'll have to wrap things up here. It's kind of hard for me. I wrote this up this morning. It was kind of hard. There were so many great points that our speakers had. I tried to boil them down a little bit. One of them is integrated HVAC-D, which is, remember, dehumidification built into the HVAC unit. It has higher upfront costs, but great benefits, more energy efficient, requires less maintenance, provides better climate control. Yeah, that's what we want, and can be diagnosed and tuned remotely. Totally cool. Critical maintenance points for HVAC-D, and I would say probably most HVAC, need to be conducted by a trained professional in refrigeration, either hired or contracted, not a grower. Your grower's not going to be able to pull this off, okay? So professionally trained. Grow facilities require environmental controls, bottom line, with properly placed high-quality sensors. It's not something you're going to be able to do manually switching off and on fans and stuff, okay? For selecting equipment and controls, consider the locality, complexity, and required expertise. As Robert pointed out, both simple and advanced systems can be effective. It all depends on those variables: locality, complexity, and required expertise. Lastly, preventative maintenance is a must-do. Plan on it, or you're going to have huge troubles and have a hard time staying in business, because it's just the repairs are going to kill your crops, emergency repairs, and the cost of those repairs are going to kill your budget. It should be prioritized, as Robert pointed out, towards equipment that is critical for crop survival, okay, and is most at risk of failure. All right, great points. I want to thank NYSERDA and the Office of Cannabis Management for sponsoring this webinar. I had a great time. I learned a lot. I totally enjoyed bringing this information to you and working with our panelists. I want to thank Chip Seidel and Robert Fisher for being our expert panelists. For Carmen Azretti and Bryce Carlton, I'm Rob Eddy, and we thank you for your attendance today.